Yes, good afternoon, dear students. Today I will start the third chapter, that is chemical kinetics. I will teach you some important topics of chemical kinetics. See here. First of all, so what is chemical kinetics? What we study in this chapter. So see here, the branch of chemistry which deals with the study of the reaction rates is known as chemical kinetics. Chemical kinetics also involves the investigation of reaction mechanism, that is the conditions of concentration, temperature, pressure, catalyst, which control the rates of different reactions. So this means in chemical kinetics, in the chapter of chemical kinetics, we study about the rate of chemical reaction as well as the conditions in which the rate of reaction depends, and also the mechanism of the chemical reaction, that how does it take place, in how many steps it takes place. Now, classification of chemical reactions on the basis of reaction rates. First, instantaneous reaction means the chemical reactions which are completed the moment the reactants are mixed are called instantaneous reactions. Generally, the reactions of ionic compounds in aqueous solutions belong to this category or type. This means this reaction takes place very fast. It happens rapidly. As soon as you will mix the moment you mix the two solution, at the same time you will get the precipitate or the new product. For example, on mixing aqueous solution of AgNO3 and NaCl, a white precipitate of AgCl is formed in no time. Without taking any time, it forms. Now, why does such reactions occur very fast, rapidly? In fact, in ionic reactions, the reactants immediately change into ions in solution without involving any energy. Hence, these ions simply regroup and form products. So how do they regroup? See here. When we mix silver nitrate and NaCl, we have following ions in the container, and the ions they regroup, means nitrate ion attached with the sodium, and chloride ion will attach with the silver ion, and you will get the silver chloride as precipitate. Now, since these reactions are extremely fast, it is therefore not possible to study their rates. Now, the second type of reaction which we find in our surrounding or in our practical life, that is extremely slow reactions. Certain chemical reactions are very slow. For example, fermentation of sugar in the presence of yeast, rusting of iron, setting of cement, formation of coal and petroleum, etc., are the examples of such type of reactions. Thus, it is also not feasible to study the rates of such reactions. Now, the third type of reaction is reactions proceeding at a measurable speed. Following are the reactions which proceed at a limited speed and their rates can be measured. For example, decomposition of hydrogen peroxide, reaction between acetic acid and ethyl alcohol, oxidation of ammonia. These are the examples of reactions proceeding at a measurable speed. Hence, only the rates of such reactions can be studied easily in the laboratory. Very important thing, with the development of latest techniques such as lasers, it is also possible to study even the kinetics of very fast reactions. Now the rate of chemical reaction. So what do you mean by the rate of chemical reaction? The next topic is the rate of a chemical reaction means the speed with which a chemical reaction takes place. As a reaction progresses, the reactants are consumed and the products are formed. So we find that in our practical life or in experiments that as the reaction progresses, reactants are consumed and products are formed. Thus, the rate of a reaction implies the decrease in molar concentration of the reactants per unit time or increase in molar concentration of the products per unit time. In general, the rate of a chemical reaction is the change in the molar concentration of the species taking part in a reaction per unit time. So, this is the definition of the rate of reaction. Again, I am repeating it. Listen attentively. Try to listen it very seriously. The rate of a chemical reaction is the change in the molar concentration of the species. Species means both reactants and products taking part in a reaction per unit time. Thus, reaction rate is equal to the change in molar concentration by time taken for the change. Let us consider a general reaction. R gives product P, R arrow P. R means reactants and P means product. Reaction rate with respect to R, decrease in molar concentration of R by time taken for the decrease, that is minus delta molar concentration of R by delta T, and reaction rate with respect to P product, increase in molar concentration of P by time taken for the increase, that is plus delta molar concentration of product by delta T. Here delta T is equal to T2 minus T1, where T1 and T2 are the different times to represent the concentrations of reactants and products. Means T1 is a time where you find the concentration of reactants and products, and T2 is the another time where you find the concentration of reactants and products. Now, significance of negative sign. So, what is the significance here? Because you see here in this rate of reaction there is a minus term, but here is a plus term. So, why? What is this significance? That the minus, in one way we know that as the reaction progresses, the molar concentration of the reactants decreases. This means that at any stage in the reaction, the concentration of the reactants is less than their initial concentration. Therefore, the change in concentration or delta molar concentration of R is equal to final concentration minus initial concentration, which is negative. But as the rate of reaction is always positive, therefore negative sign is placed before the expression of the reaction rate to make it positive. So, when you will get two concentrations at different times, the one is the final concentration when the reaction after some time, when the concentration you will get, suppose the reaction starts, and after some time, 5 minutes, 10 minutes, 10 to minutes, you note the again the concentration of either reactants and products, that is the final concentration. So when you subtract the initial concentration from the final concentration in respect of reactant, you will get the quantity in negative, and so negative multiplied with negative sign will become positive, so the reaction rate will be positive. That's why this is the fact that we put minus sign when we represent the rate of reaction in terms of the molar concentration of the reactant. But it is not needed in case of products, since the negative sign is not needed in case of products, since the change in concentration is always positive here. In this particular reaction, suppose that is R gives P, the rate of decrease in the concentration of reactant is the same as the rate of increase in concentration of product. Therefore, minus delta molar concentration of R by delta T is equal to the delta molar concentration of product by delta T. But this is not valid for all types of chemical reactions. Means this is very simple reaction. That is, in case of here the R is 1 mole, P is 1 mole. But what will happen for the reactions in which way some substance in reactants are in 2 mole, someone in 1 mole, the product in 3 mole or 2 mole or 1 mole, what will be the expression for the rate of reaction in that case? Let us understand here, but that's why it is told that it is not valid for all types of chemical equations. For example, in the reaction A plus B arrow 2C, we find that the rate of disappearance of A and B is the same, but the appearance of C is twice as compared to them. Thus 2 multiplied rate of disappearance of A will be equal to 2 multiplied rate of disappearance of B equal to rate of appearance of C, or rate of reaction will be represented like this: minus delta A by delta T is equal to minus delta molar concentration of B by delta T is equal to 1 by 2 delta molar concentration of C by delta T. For a reaction N2 plus 3H2 2NH3, the rate of reaction will be minus delta molar concentration of nitrogen by delta T is equal to minus 1 by 3 delta molar concentration of H2 by delta T is equal to 1 half delta molar concentration of nitrogen by delta T. Thus, coefficients of the reactant and product species involved in the reaction are called stoichiometric coefficients. Hence, we can say that rate of a reaction is equal to the rate of disappearance or appearance of a substance in a chemical reaction divided by its stoichiometric coefficients, units of rate of reaction. So see here what will the unit. The concentration are normally expressed in moles per liter and the time in seconds or minutes. Therefore, by definition, the units of the reaction rate are mole liter inverse S inverse or mole liter inverse minute inverse. So this is the unit of the rate of the reaction. Now on the basis of this expression we will learn something related to the concept disappearance and appears in your next class, and also in the instantaneous rate of reaction and the average rate of reaction. I will teach you in the next class about the average rate reaction or the instantaneous rate reaction with the help of graph or the expression. Thank you. You will first I am sending the text material through the PDF file in your WhatsApp. You will first write the thing in your notebook and then you will open my video, and with the help of video and your index finger putting on the text material you will learn the concept of the first topic today, concept of the rate of reaction and the different types of reaction. I think that you will understand sure without any doubt.